Uh, all right. This is Mohammadmehdi from University of Southern California, and now I want to introduce our paper on the unfairness of popularity bias in book recommendation with my co-authors Hossein and Mahdi. Okay. Popularity bias refers to the problem that popular items are recommended frequently, while less popular items are recommended rarely or not at all. Not tackling the popularity bias might cause the market to be dominated by a few well-known brands and create a Matthew effect in which popular items get even more popular. Two common approaches has been adopted by researchers for evaluating the popularity bias. The first approach is from the item's perspective. In other words, measuring how frequently long-tail or non-popular items are being recommended in the system. The second approach is from the user's perspective that measures how well the user taste in popular items is calibrated in recommendation lists. To show the concept clearly, you can see in the above picture that a user has 30% non-popular items in her profile. User expectation is to see some percentage of that non-popular items in the recommendation list as well. However, in practice, we noticed that most recommender systems recommend majorly popular items and very close to 100%. In this paper, we examine closely the second point of view in evaluating popularity bias. The motivation behind this study is to verify whether the hypothesis of inability of recommendation algorithms to capture users' taste in popular items holds given different domain, data characteristic, and based on recommendation algorithms. To this purpose, we chose the book domain and book crossing dataset for various reasons. The first reason for choosing the book domain is popularity bias is highly influenced by data biases and characteristics such as the number of interactions per items or users, sparsity, and unbalanced distribution of interaction among items. The characteristics of book crossing datasets differ significantly from the study of Abdollahpouri and colleague, where they studied the calibration of popularity bias on the movie lens dataset in the movie domain. In the movie lens domain, we have way less sparsity, as well as having around 10 times more interaction per items and per users. This makes book crossing datasets completely different in terms of data characteristics than the previous study. Also, there are several aspects of book domain in recommendation that make them different, challenging, and somehow more important than recommendation in entertainment industry. For example, although book reading must become more prevalent in the society, the investigation proves the absolute opposite. That is, the practice of reading for pleasure or education is declining, particularly among the young. As a result, it is important that the book that is being recommended matches the preference and expectation of the users using the system. This motivates us to use the book crossing and book domain for our case study here. So now I want to address our first research question, which is how much are different individuals or groups of users interested into popular books, similar to the Abdollahpouri and colleague, which they investigated this research question in the movie lens dataset. So first of all, we define a book as a popular item if, when sorted by number of readers, it falls within the top 20% category of the most read books. Given this definition, in the dataset, we noticed that around 83% of users have read at least 20% of unpopular books. In this slide, we show two correlation plots of users' profile size versus the number of popular books and average popularity of books. As you can see, when the user profile size increases, the number of popular books in the profile increases as well. However, the average popularity of books decreases because we see a negative correlation in the second graph. And both of these correlations are meaningful given 5% p-value. This suggests that active users are more likely to read unpopular books than popular books. To investigate the popularity bias from the user's perspective, we divided all users into 3 groups according to their profile's ratio of popular item. In other words, after sorting them by the ratio of popular item, we categorize the top 20% of this list as bestseller focused users, and the bottom 20% are categorized as the niche users, and the rest falls within the diverse category. The average profile size of niche and diverse users are relatively larger than bestseller users, confirming our previous plots in the previous slides. This suggests that we have more training data, we have more information for the niche and diverse users, which are less interested into popular items. Now we want to investigate how does the popularity bias in recommendation algorithms impact users with different tendency toward popular items. To this purpose, we use several evaluation metrics such as precision, recall, MAE, NDCG, and delta gap, which delta gap refers to delta group average popularity and is calculated as the normalized difference of average popularity score in the recommendation list and user profile. So the difference between these two shows how well the recommendation calibrated the user's taste. We also chose several baseline recommendation models, actually 11 baseline recommendation models, including baselines such as random most pop BPR and KNN approach, user KNN, neural network approach such as neural matrix factorization and variational autoencoder collaborative filtering, and several matrix factorization approaches. Here we plotted book popularity versus the frequency of recommendation. As you can see, generally, there is a positive correlation between book popularity and recommendation frequency. To put it differently, this graph shows how well different recommendation algorithms are capable of giving exposure to long tail or non-popular items. The random and most pop are 2 extreme sides in terms of popularity bias, in which most pop would completely recommend popular items, as you can see in the graph, in the second graph. And on the other hand, random would not consider popularity as a criteria and gives a uniform exposure to all items. Ideally, we would be looking for models that behave similarly to random algorithm in terms of exposure, while also giving a good accuracy or relevance to users. BPR, neural matrix factorization, and most pop models are very similar in terms of their performance in exposure of popular items. And on the other hand, PF, VAECF, user KNN, and PMF seems to be more diverse and seems to be better in terms of popularity bias as far as the exposure is concerned. In this graph, we investigate the effect of popularity bias on different user groups separately. Just as a reminder, delta gap or delta group average popularity of 0 would indicate a completely fair recommendation, meaning that average popularity of recommended books matches the average popularity of user profile. As can be seen, niche users receive significantly higher average delta gap values, followed by diverse and bestseller focused users, confirming Abdollahpouri and colleagues' result. Another important thing to notice here is that even bestseller groups are receiving on average delta group average popularity of 125%, showing that even though they are already interested and they are already skewed toward popular items, the algorithm further propagate this popular item in the user profile. The same type of conclusion can be drawn here as well. Random matrix factorization and NMF models provide the fairest recommendation as far as the delta gap values are concerned, while most pop, BPR, and neural matrix factorization suffer the most from propagation of popularity bias among all user groups. In this slide, we also included the other side of this study, which is the accuracy of the models across different user groups. We further measured a statistically significant difference using the two-tailed t-test at a 95% confidence interval. As you can see, in most cases, we see 2 stars on the bestseller groups row. This indicates that the performance of bestseller groups is statistically significant and better than the performance of diverse and niche users. And this is despite the fact that average user profile size of users with diverse and niche tastes was significantly higher than those of the bestseller taste. As a result, this shows that algorithms commonly fails to capture the taste of users in regards to popularity bias, although the training sample is way larger for the users with niche and diverse interest. We further plotted the correlation between NDCG and delta gap metric. As you may notice, there is a meaningful correlation on 5% p-value level in the diverse and bestseller focused users. This shows that models which are capable of reaching high accuracy would fail from the unfairness of popularity bias. In other words, models that were able to give the highest accuracy was suffering the most from the popularity bias and the fairness issues in this study, while we haven't seen a meaningful correlation for niche group users. As conclusion and future work, we can mention that first of all, we found out that different users have a considerably different tendency toward popular items. Moreover, we noticed that most state-of-the-art recommendation algorithms are providing significantly lower recommendation quality to niche and diverse users, despite them having a larger profile size. Also, propagation of popularity bias affects all user groups, but the magnitude differs from different user groups. The other things we found out is that the algorithms could differ significantly in their ability to capture users' taste based on the domain. For example, negative matrix factorization was suffering from popularity bias in the movie domain in the previous study, while providing a completely fair recommendation in the book domain. So a promising future research direction would be to identify what is the underlying reasons for these variants. In particular, which feature of the data, is it the sparsity, average user interaction, and so on, plays the primary role in propagating the popularity bias. We also noticed that an underlying trade-off seems to exist between personalization and fairness of popularity bias in various algorithms. This motivates the need for further research into implementing a recommendation algorithm that can find the optimal trade-off between personalization and the unfairness of popularity bias to enhance the system's overall effectiveness. Finally, it would be interesting to investigate popularity bias on other domains and algorithms such as session-based, multimodal recommendation, content-based, and so on, as well as incorporating further evaluation metrics such as novelty and coverage in analysis. And finally, we made all our codes and pipelines open source, and the dataset is also released on GitHub. And you can even find more information on our results, graphs, and findings on our website, which you can find the link in this slide. Thank you, everyone.